to make sure that you distribute this negative. I'm subtracting all of G. So you see how all this is in parentheses. All of G is.
I need seniors' last name beginning with B through F, please, to go to the high school library for their pictures. Seniors B through F. Thank you.
When we multiply here, notice that we had to distribute. Right? I'm multiplying two binomials. That means to distribute. And then the division, they really didn't divide anything. They just left it the way it was. But when we do division, we have to worry about restricting our domain because we have to make sure we cannot divide by 0. So they set the denominator equal to 0 and solve. So the x cannot be 1 or negative 1. Otherwise, we get a divide by 0 error. So that's the most important thing about division. All right, that's what I just talked about there. All right. Okay, we've got f of x is 2x plus 1. G of x is x squared plus 2x minus 1. It tells me to find f plus g. So what are we doing? We are adding the two functions. We are adding f and g. So I'm going to write down f of x, which is 2x plus 1. And I'm going to add g of x, which was x squared plus 2x minus 1. Now combine your like terms. Is there anything like x squared? No. Anything like 2x? Yes, 2x. So that is 4x. Anything like 1? Negative 1. So that goes to 0. So now I've combined them. So I have now found this is f plus g of x equals that. That's the first part. That's all I've talked about so far, is doing that. Any questions? Now, it tells me to evaluate what happens when x is 2. Okay, well, guess what I'm going to do? I'm going to plug in 2. I'm going to find f plus g of 2. That's going to equal 2 squared plus 4 times 2, which is 4 plus 8, which is 12. We should be finished. Okay, geez. Oh, we should be finished now. What do we get when we add them? X squared minus x plus 1. I'm not done that yet. This is the first part.
Let's say x equals 2 plus something.
What I wrote or the question?
Got a question.
It says evaluate the sum when x is 2. So what's a sum?
Oh, it's like ending the whole sentence.
Yeah.
Oh.
Yeah. There's a period after that. See if I scroll over, period. That's it. It's over.
That was confusing. I didn't know if it was like adding on like 2 points.
No, not 2.4. No. Just 2.
Because like you never know with math.
Yeah, that's true. So there's nothing after the decimal, so we can assume it's a 0. So 2.0, 0, 0, 0, 0, 0, 0, 0.
Maybe it was 2.1. They rounded it to.
No rounding. Okay, so when I evaluate f plus g at 2, 2 squared minus 2 plus 1, you should get, tell them, Joe. 3, yes, 3. As in the number of quarterbacks Sam has on his roster. Any questions here? Okay, so now it tells me find f minus g and then evaluate the difference. So again, the only thing that I want you to be careful of here is we are subtracting all of g. So when I plug that in, I'm going to put f of x, which is 2x plus 1, then minus all of g. So minus x squared plus 2x minus 1. Now the important thing here is we're going to have to distribute that negative. So this is a negative x squared, a negative 2x, and a positive 1. And now then combine my like terms. So negative x squared, I have nothing like that. 2x minus 2x cancels. And then plus 1 is plus 2. All right, so real quickly, if I graph this, what would it look like? What's its parent function?
X squared.
X squared. What are the transformations that have occurred?
Right 2.
Nope.
Up 2.
Okay, that should be the second thing you do. The first thing you should do is a reflection, because I have a negative outside the function. So I'm going to reflect that over the x-axis, change the sign of y, and then I'm going to go up 2. If you graphed it on a graphing calculator, we could back that up. That's exactly what we did. All right. Now, let's evaluate what happens at f minus g at 2, when I'm going to plug in 2. So I've got negative 2 squared plus 2. Be careful here. Negative 2 squared is negative 4. Plus 2 is negative 2. Because that negative is outside, it does not get squared. The negative must be part of the x. The only thing we are squaring is x, not the sign in front of it.
11. Yes. Yes.
No, that's not the first answer.
A squared plus x minus 1.
F minus g of x is x squared plus x minus 1. That's the first thing I have to do. Then I can plug in 3. That's going to be 3 squared plus 3 minus 1, which is 11. The number kickers Kroll would have if they would let him. Okay. I meant quarterbacks. I said kickers. I meant quarterbacks. I ruined the joke. Sorry, Sporky. Any questions here? If you subtract all of it, you have to distribute. Multiply. Now, multiply is a little bit more difficult, but it still should be a gimme in my book. Okay, so if I have to do f times g of x. See, I have f and g written right beside each other. That means multiply. So f times g of x, I'm going to write down f of x, and I'm going to multiply it by g of x. I have to distribute. And it's x cubed minus 3x squared. And that's my first answer, right, Joe? F times g of x is x cubed minus 3x squared. Then the second part is to evaluate when we're at 4. So I'm looking at f times g at 4. That's going to be 4 cubed minus 3 times 4 squared. So that's going to be 64 minus...
48.
That's going to be 16, ain't it? Yeah. Thanks. Because 4 squared is 16. 16 times 3 is 48. So 64 minus 48.
I didn't get that far.
Oh.
I'm good, alright?
I was just right.
Okay, so here we go. Let's do it.
This one has issues.
This has issues.
It has issues. Sounds like me.
I agree. You should get x squared minus x cubed.
Yeah.
That's what I got. That's issues? Why is that issues? Well, yeah, I don't understand y'all today. Okay, so I get 3 squared minus 3 cubed, which is going to be, that's wrong, negative 18.
Sir. 3 times 3 times
Listen, I need your hand out.
Hey,
Hey, bro, we got you.
All right, now then, I've got f of x and g of x. It tells me to find f divided by g.
I'll start to use that.
So f over g of x is going to be radical x over radical 4 minus x squared. Now later on we're going to have to rationalize this denominator, but for now we can leave it like it is.
Like you do it on the board, maybe?
Now, it tells me to find the domain, which means the possible x values. So the domain always defaults to negative infinity to positive infinity. But there are 2 problems I could encounter with the domain. What are they? Divide by 0. Or take the square root of a negative. Could I divide by 0 here? Yes. Could I take the square root of a negative? Yes, twice. So I've got 3 possible problems with my domain. So I'm going to have to solve for all 3. No, this is not. That's why I said they were mean. So, first, we know, let's do square roots cannot be negative. So what's underneath the radical must be greater than or equal to 0. And what's underneath the other radical must be greater than or equal to 0. So this one's solved. That's nice of them. All right, so now the next one is the hard one. I'm going to move x squared over. It becomes positive. So I've got x squared must be less than or equal to 4. So again, if I rewrite that, x squared must be less than or equal to 4.
Excuse me, teachers. I'd like for seniors with the last name beginning with G through S to go to the high school library, please, for their pictures. G through S. Thank you.
Okay. So, how could we solve this? We could take a square root. Okay, but that doesn't really work great here because I get x less than or equal to plus or minus 2. But that's not really how that's supposed to work. So let's think about it. I take a number and I square it, and it must be less than or equal to 4. So let's figure out what can I square that gives me exactly 4. 2. Or negative 2. If I square negative 2, I also get 4. And if I square 2, I get 4. So those are kind of the boundaries. Now I need to figure out, there are 2 possibilities. Okay, so let's think about it on a number line. If I'm here at negative 2 and 2. The answers could be everything between those endpoints, or the answers could be everything on the outside of those endpoints. So let's figure out which one is correct. So like I would pick 0 because I know 0 is between them, right? If I plug in 0, does that make the inequality true? 0 squared is 0. Is 0 less than or equal to 4? Yes. So 0 should be an answer because 0 makes it work. All right, let's plug in something that's outside, like over here. Plug in 3. 3 squared is 9. Is 9 less than or equal to 4? No. So this part shouldn't work. And same thing over here. If I plug in negative 3. Negative 3 squared is 9. Is 9 less than or equal to 4? No. So the only thing that works is things between negative 2 and 2. Everybody follow that? So this part says the domain must be between negative 2 and 2. This says it must be between 0 and infinity. And I need both those to be true at the same time. So where would both of those be true at the same time? How can something be between 0 and infinity and between negative 2 and 2? Okay, I can see that that is not working for you guys. Okay, let's graph them. What I'm doing is I'm finding domains. So I've got from 0, let's use a different color, from 0 to infinity. That's the first part of the domain. The second part of my domain says it has to be between negative 2 and 2. So what makes both of those true at the same time? 0 to 2, where they overlap. It satisfies both conditions. From 0 to 2 is bigger than 0, and it's between -2 and 2. So when I combine these two things, that tells me the domain must be between 0 and 2. We follow that? I'm not finished yet. Because what have I done so far? I've made sure that I couldn't take the square root of a negative. Right? That's the first thing I did. No square roots of negatives? Check. What's the second thing I have to do? Cannot divide by 0. So I have to fix that next. So I've already got the domain restricted to be between 0 and 2. Now then I'm going to see if I need to restrict it even further. So how can I make sure I don't divide by 0? Well, let's say that the denominator equals 0. Let's find out what would break it. What would make the denominator be 0? So to solve this, I would square both sides. That tells me 4 minus x squared equals 0. Because when I square a square root, that cancels. Now then, solve this. So that's going to give me x squared is equal to 4. Square root. X is equal to plus or minus 2. Remember, when I choose to take a square root, I always account for the positive or negative. So what is this telling me? If x is 2 or -2, I get a divide by 0 problem. So it can't be either one of those things. If x is 2 or -2, it breaks it. So how can I fix this to make sure that I say 2 is not an answer? Because 2 breaks it. I would now say my domain is everything between 0 and 2, but I don't include 2. That's my final answer.
How would that not be, instead of saying choose not included, just say 0 and
Ask that again. Hopefully everybody can find f divided by g. That should be radical x minus 3 over radical 16 minus x squared. Right, can we all do that? Okay, yeah. Now, the next thing we have to do is find the domain for f divided by g. So let's just focus on that before we even do the next one. So my domain problems. I cannot take the square root of a negative. So how can I make sure I don't take the square root of a negative? What's underneath there must be positive. Must be non-negative. So greater than or equal to 0. And I have another radical. I have 16 minus x squared must be bigger than or equal to 0. Because I have two radicals, I have two problems that I could encounter. So when I solve this one, this tells me x is all things bigger than or equal to 3. So that means from 3 to infinity, the red one says we're good to go. Which means they're saying from 3 to infinity. That should be the domain. All right, now when I solve the green one, again, I get x squared is less than or equal to 16. When I take a square root, I get plus or minus 4. All right, so again, that kind of breaks it. So what we have to think about are endpoints. So what could I square to give me 16? 4 or -4. So the things that make this inequality true, they could either be between them or they could be on the outsides. So what we do is we plug in values to figure out what makes them true. So plug in 0. Does 0 work? Is 0 less than or equal to 16? Yes. So that means the stuff between them has to work. Because 0's between them and it works, so everything else must work. You can plug in more numbers if you want to test me. If you plug in 2, 2 squared is 4. Is 4 less than or equal to 16? Yes. Everything between them works. Now try something on the outside. So like try 5. 5 squared is 25. Is 25 less than or equal to 16? No. So 5 doesn't work. Try negative 5. Negative 5 squared is 25. Is 25 less than or equal to 16? No. So according to this part, this tells me the domain must be between negative 4 and 4. So on my graph over here, it says from negative 4 to 4 should work. And so I'm looking for the overlap, which is where? 3 to 4. So the domain is all things between 3 and 4, including 3 and 4. To start with. So what have I done so far? I found what makes radicals negative. Check. What I have to do next? What makes me divide by 0? That could also be a problem. So I'm going to take what's in the denominator and find out what makes it 0. Because whatever makes that 0 is a problem. I can't use it. So I square both sides. That tells me 16 minus x squared equals 0. Then I get x squared equals 16. When I take a square root, I get plus or minus 4. So if I plug in 4 or negative 4, I get a problem. All right, well, negative 4 is already excluded. I'm not using it. But now then, I originally said 4 would work. But this tells me 4 breaks it. So I have to make sure I don't count 4. So instead of including 3 and 4, I include 3 and everything up to 4, but not including 4. Square root of x minus 3. Everybody good with that? Now when you found the domain, what's the first thing that we noticed? Square roots of negatives cannot happen. So this is exactly what we just did before. 16 minus x squared must be bigger than or equal to 0, and x minus 3 must be bigger than or equal to 0. So where was the overlap? The overlap was between 3 and 4. Again, from those parts. That part shouldn't have changed.
Where did you get the 4 from?
By 0 part. Because now, what's going to make me divide by 0? If the square root of x minus 3 is 0. That's what breaks it now. Because that's what's in the denominator. So if I square and square, I get x minus 3 equals 0. So now this tells me when x is 3, I get a problem. I get divide by 0 problem. So I cannot include 3. So I include the thing right after 3 up till 4, including 4.